The 2026 Minoga helicopter is shaping up to be one of the most important rotorcraft developments in modern naval aviation, and it's not just another upgrade that represents a generational shift. Designed as Russia's next-generation naval helicopter, Minoga is expected to replace the long-serving Ka-27 family, which has been the backbone of shipborne helicopter operations for decades. That alone tells you how serious this project is, because replacing a platform that proven is not about small tweaks, it's about rethinking performance, survivability, and mission flexibility from the ground up. What makes Minoga immediately stand out is that it's being built with the future battlefield in mind, not the past. Modern naval warfare is all about information, speed, and precision. Submarines are quieter, missiles are faster, and electronic warfare is more intense than ever. A helicopter operating over open water has to detect threats earlier, react faster, and survive in heavily contested environments. Minoga is expected to answer those demands with a completely new avionics architecture, advanced sensors, and far greater automation than older naval helicopters. One of the most talked about elements of Minoga is its coaxial rotor system, a CMIV design trademark. Unlike traditional helicopters with a main rotor and tail rotor, coaxial systems use two counter-rotating rotors stacked on top of each other. This eliminates the need for a tail rotor and gives several advantages at sea. First, the aircraft can be more compact, which is crucial when operating from crowded ship decks. Second, it offers excellent stability in strong crosswinds, something every naval pilot appreciates when landing on a moving ship. Third, coaxial helicopters often have impressive maneuverability, especially at low speeds and in hover, which is essential for anti-submarine warfare and search and rescue missions. Power is another area where Minoga is expected to leap forward. New generation engines are projected to provide more horsepower while also improving fuel efficiency and reliability. Over the ocean, engine reliability is not just a maintenance issue, it's a survival issue. More power means the helicopter can carry heavier mission equipment, more fuel, or additional weapons without sacrificing performance. It also improves hot and high capability and overall safety margins. But raw power is only part of the story. The real revolution is likely to be in the cockpit and onboard systems. Minoga is expected to feature a glass cockpit with large multifunction displays, digital flight controls, and advanced flight management systems. This reduces pilot workload, especially during complex operations like dipping sonar deployment or night landings on ships. Modern naval helicopters act as flying sensor hubs, and Minoga is designed to process and share data in real time, linking with ships, drones, and command centers through secure data links. Anti-submarine warfare, or ASW, remains a core mission. Submarines today are stealthier than ever, so helicopters must rely on a combination of active and passive sensors. Minoga is expected to carry an advanced sonar suite, including a dipping sonar and sonobuoy systems. The key isn't just detecting a submarine, it's tracking it continuously while coordinating with surface ships and possibly other aircraft. Faster data processing and improved acoustic systems could allow crews to classify contacts more quickly and with greater confidence. Surface warfare capabilities are also evolving. Naval helicopters are increasingly used to detect and engage small surface threats, from fast attack craft to asymmetric threats in littoral zones. Minoga is expected to carry modern radar systems capable of scanning both sea and airspace. Combined with electro-optical sensors, this allows crews to identify targets at long range, day or night. This kind of multi-sensor fusion dramatically improves situational awareness, turning the helicopter into an extension of the ship's size. Survivability has become a major design driver. The modern battlefield is full of radar systems, infrared seekers, and electronic attack. Minoga is expected to incorporate a comprehensive defensive aids suite, including missile approach warning systems, radar warning receivers, and countermeasure dispensers. Electronic warfare capabilities may allow it to jam or deceive certain threats, improving its chances of surviving in high-risk areas. Structural design and materials could also help reduce vulnerability and improve crashworthiness. Another interesting angle is modularity. Modern military platforms are increasingly built with open architectures, allowing new equipment to be integrated more easily over time. Instead of being locked into one configuration for decades, Minoga may be able to receive sensor upgrades, new communication systems, or mission packages as technology evolves. That keeps the helicopter relevant longer and reduces the need for entirely new airframes. Every time systems advance, naval operations demand corrosion resistance and ruggedness. Saltwater environments are brutal on aircraft, so materials, coatings, and maintenance design are crucial. Minoga is expected to benefit from modern manufacturing techniques and improved protective treatments, potentially reducing maintenance hours compared to older helicopters. Easier maintenance means higher availability rates, a critical factor when fleets need aircraft ready at short notice. The role of unmanned systems is also shaping helicopter design. While Minoga itself is a crewed aircraft, it may operate alongside drones, sharing sensor data and even controlling certain unmanned assets. This manned-unmanned teaming concept extends the helicopter's reach without putting crews at additional risk. A helicopter could deploy a drone to scout ahead or relay targeting information while staying at a safer distance. Search and rescue is another mission where improvements matter. Over open sea, response time and equipment capability can mean the difference between life and death. Enhanced navigation systems, better night vision compatibility, and improved hoist and medical support setups could make Minoga a more effective SOAR platform. Increased cabin space and better ergonomics would also help crews during demanding rescue operations. Transport and utility roles shouldn't be overlooked either. Naval helicopters often move personnel, supplies, and equipment between ships or from ship to shore. Higher lift capacity and improved stability can make these tasks safer and more efficient. In humanitarian missions, such helicopters often become lifelines, delivering aid to areas cut off by disaster. From a strategic perspective, introducing Minoga represents an investment in long-term naval aviation capability. Replacing aging fleets isn't just about keeping numbers up, it's about ensuring compatibility with modern digital warfare environments. Ships today are highly networked, and aircraft must integrate seamlessly into those systems. A helicopter that can't share data quickly and securely is at a disadvantage. Training and simulation are also likely to evolve with this program. Modern helicopters often come with advanced simulators and digital support systems that allow crews to practice complex missions without flying every hour in a real aircraft. That reduces cost while improving readiness. In the bigger picture, Minoga shows how naval helicopters are no longer just support assets. They are becoming central nodes in a networked force, gathering information, extending sensor coverage, and sometimes delivering precision effects. The helicopter is no longer just a flying torpedo carrier, it's a mobile command, surveillance, and response platform. By 2026, as more details emerge and prototypes mature, Minoga could represent a clear sign of how future shipborne aviation will look: smarter, more connected, more survivable, and more adaptable. It's a reminder that even in the age of drones and long-range missiles, the helicopter remains an incredibly flexible tool, able to hover, search, rescue, hunt, and support in ways few other aircraft can match. If the expectations around Minoga are realized, it won't just replace an old helicopter. It will redefine what a naval helicopter is expected to do in the 21st century, blending traditional roles with cutting-edge technology to meet threats that are faster, stealthier, and more complex than ever before.